Okay, this is lesson 0.3, and this is transformations of a function. If you remember, there are 4 different types of transformations you can have for a function, and they fill a position in the function notation. If you have a value in front of the function multiplying, that's your A. If you have a function, or if you have a value outside the function, so outside the bracket of the function, adding or subtracting, that's C. If you have a value inside the function multiplying the x, that is K, and if you have a value inside the function being added or subtracted directly to x, that's D. The A, K, C, and D all pose different types of transformations. The A value is a vertical stretch or compression. Or, if it's negative, it can be a reflection. K is a horizontal stretch or compression. Or if K is negative, it can be a reflection. D is a horizontal shift. And C is a vertical shift. Now, when you're applying transformations to a function and showing the transformations graphically, it's very important that you apply all the stretches or compressions and reflections first. Order for those doesn't matter, and then you follow and apply the shifts, vertical and horizontal, and the order of those two doesn't matter. But it's very, very important to apply stretches and compressions first, then shifts. The table below, there was a typo on my page, so I corrected them. They'll be corrected on your handout. Here are all the types of transformations and when they will be each type. So that C value that's being added outside the function, if it's positive, we're going up. If it's negative, we're going down, the way you would expect. For D values, since the base function has x minus D, they'll appear as the opposite. So if D is greater than 0, if D is a positive number, we will shift to the right. And that would look like, for example, that would look like f of x minus 2. That would be 2 to the right. If it said f of x plus 2, that would be 2 to the left because the D value must have been negative, because we would be subtracting a negative, which is like adding. For the A value, the number in front of the function multiplying, if it's greater than 0, we have a, not greater than 0, it should be greater than 1. It is a vertical stretch by a factor of A. So if A is 2, that's a vertical stretch by 2. But if A is a number between 0 and 1, it's a compression. So if the number was a half, it would be a compression by a factor of not a half, but the reciprocal. So if the value of A is a half, it would be a compression by a factor of 2. You flip the fraction 1/2 to express it as a compression of 2. All things we did in 11U, but we need a refresher because that's a little tricky with the flipping. But we'll get back in the groove, we'll get used to it. K. K is your horizontal stretch or compression. If K is bigger than 1, we have compression. So if K is 2, we have compression by a factor of 2. If the value is between 0 and 1, it's a horizontal stretch. It's a stretch by a factor of 1 over K. So remember, if you have a fraction and you're saying stretch or compression, you need to flip it. So if we have K of a half, we would flip it, we'd get 2, and we'd say stretch by a factor of 2. Now if we remember, if A is negative, we have a vertical reflection. That's over the x-axis, so flipping vertically. If K is negative, we have a horizontal reflection, so reflecting over the y-axis. So to review these, we're going to do it 2 ways. The first way I'm going to show you by transforming the graph, and then the second way we're going to transform using mapping notation. So let's take a look. So here's our function. It's made up of a couple points connected with the line. I'm going to highlight a couple of points that are features of this graph. These 4 points define this graph. And it's the function f of x. This is a function because it passes the vertical line test. And we're going to transform it using these transformations. So what are these transformations? Well, we need to be able to identify the a, the k, the c, the d. So in order to do that, we need to make sure inside the bracket that the k is common factored away, which it's not. You'll know it is if after the number in front of x we have a bracket. Since we don't, we have to common factor k. So it would look like this. Common factor 2, from 2x and negative 2, we get 2 times x minus 1. And now we are common factored. So now we can pick out the a, the k, the c, the d. A is the number in front. A is negative 0.5. K is the number in front of x. So k is 2. D is the number being added or subtracted from x. D would be 1. And there's nothing after, so c is 0. So we have 3 transformations to perform. We have an a of negative 1/2, we have a k of 2, and we have a d of negative 1. Now remember, on the last page, I reminded you to do your stretches and reflections or compressions first, and then your shifts second. So in this example, we have a vertical reflection, a vertical compression, a horizontal compression, and a shift right. So we're going to do all these reflections and compressions first, then we're going to shift. Let's start with the vertical reflection. So we're going to do the negative part of A first. So let's do that. We're going to take all of these points and we're going to reflect them over the x-axis. So how do we do that? Well, we take the y values and we make them negative, keeping the x's the same. This point would have a y value of 4, so it becomes negative 4. This would be 1, becomes negative 1. This would be 1, 2, 3, becomes 1, 2, 3, but negative. And this point would be 5, 6, 7, 8, 9. So it would be negative 5, negative 6, negative 7, negative 8, negative 9 for the same x. There we go. We have reflected. So this graph would be y equals negative f of x. We've done the reflection. To do a vertical compression, we're going to take all the y values and bring them halfway to the x-axis. So if this is negative 4, we're going to bring it to negative 2. If this is negative 1, we're going to bring it to negative 1/2. If this is negative 3, we're going to bring it to negative 1.5. And if this is negative 9, we're going to bring it to negative 4.5. The x values stay the same. That's a vertical compression. And this would be y equals negative 0.5 f of x. Now last year we did a lot of mapping notation, not a lot of transforming using the graph. So this might not be as familiar, but that's okay because we don't need to necessarily use this strategy, but I am going to review it. If you prefer to do it this way, that's fine. I'm going to show a mapping notation example next. K. K is 2. That would be a horizontal compression. So that means we're going to take all these points and we're going to go halfway to the y-axis. So I'm going to take this point, which is at 1, and bring it to half. This point's on the x-axis, so it doesn't move. This point's negative 3, so it becomes negative 1.5. This point's 4, so it becomes 2. And we end up with a new graph again. And this one is y equals negative 0.5 f 2x, because we've now applied the 2. And now the last thing we need to do is shift it 1 unit to the right. So 1 whole unit. This is at negative 1.5, so it goes to negative 1/2. This point's at 0, so it goes to 1. This point's at a half, it goes to 1.5. And this point's at 2, it goes to 3. And there we end up with our last graph. Now the advantage to doing it this way is it's nice to do the transformations one at a time. Make sure that we get it right. The hard part is your graph can get a little crowded, because that is a lot crowded. But our final answer would be correct whether we did mapping notation or transformations. This is for 2, x minus 1. And that's how you can do transformations graphically. Again, mapping notation is the way we predominantly did our transformations last year, so let's do an example using mapping notation. Given the function y equals the square root of x, transform to get the function y equals 2 square root of negative 2x minus 4. Again, we have not common factored the k, so let's do that really quickly. 2 square root, we're going to common factor negative 2. So negative 4 divided by negative 2 is positive 2. There we are. We can now read the a, the k, the c, and the d. A is 2. K is negative 2. C, there's nothing being added or subtracted outside the square root, so C is 0. And D is negative 2, because remember, it's the opposite sign of what you see. And we're going to use those to do our transformations. How do we use those? Well, you may remember mapping notation. Mapping notation is x over k plus d and ay plus c. Let's take your original x's and y's and use the AKC's and d's to get new points. So what were the original x's and y's? Well, it depends on what your function is. Our function is the square root of x, so we need to remember what the square root of x is. X and y, the square root of x. What's the square root of x? That's the parent function, and it has a few key points. 0, 0, 1, 1, 4, 2. We could keep going, 9, 3, 16, 4. They just won't fit on the graph, so I only did 3 points. So let's graph those really quickly. 0, 0, 1, 1, 4, 2. So we got those 3 points. And that's y equals the square root of x. Now, instead of vertically stretching by 2, compressing horizontally by 2, reflecting horizontally, and shifting 2 to the left, we can just use mapping notation. We take our original table, and we do x divided by k plus d for all of our x's, and ay plus c for all of our y's. So let's write our mapping notation. X divided by k, k is negative 2, so x divided by negative 2, plus d, d is negative 2, so subtract 2. We end up with x over negative 2 minus 2. Ay plus c, 2y plus 0, so just 2y. That's pretty easy for the y's. We'll do the y's first. We just multiply all our y's by 2. 0 times 2 is 0, 1 times 2 is 2, and 2 times 2 is 4. For our x's, a little bit trickier. We're going to divide by negative 2 and then subtract 2. 0 divided by negative 2 is 0, minus 2 is negative 2. 1 divided by negative 2 is negative a half, minus 2 is negative 2.5, which is negative 5 over 2, or you can write negative 2.5, that's fine. 4 divided by negative 2 is negative 2, subtract 2 is negative 4. And you might use a calculator to get those. If you can do them in your head, that's fine too. But now we've got our new points, we just have to graph those new points. The really important thing to remember when you're doing the square root function is that 0, 0 was a starting point. So the transformed version, negative 2, 0, will be a starting point. The arrow will go after the negative 4, 4 point. Negative 4, 4. So it looks like we're going this way, so I'm going to extend a little bit and draw an arrow. It's really important to remember which one's the start, which one's the arrow. Negative 2.5, 2 would be right here. And then we can just connect. And there we have it. This is y equals 2 square root negative 2x plus 2. Or we could write the original without the factor. Either way. All right, that's a review of transformations. What I would suggest is do a couple mapping transformations in your practice. And that's it for 0.3 of our review unit. And that's actually it for our quick review. We will begin with lesson 1.1 next class. Thanks for watching, and I'll see you next time.